In this video, we are going to be looking at some string functions, and these string functions we're going to be using a demo with Microsoft SQL Server. It should be noted that most SQL languages have their own derivatives of these. So for instance, a couple of the functions we're going to be using, there may be different functions that call them, but they do have many of these supported. There's only going to be a couple that we cover. So you'll want to be familiar with what the functions are in the specific SQL backend that you're looking at. However, keep in mind that they will function very similar or identical to these functions. So the first thing here that we have is we're using car index, and then we're going to be using length, and then we're going to be using replace as these first three. So we see the quick brown fox jumped over the lazy dogs is the sentence that we're working with, and we see that if we look for the car index of E, so we're starting at the very beginning here, we see that it is going to return the first E, and we see that is the number 3, and that's correct, because if you start here, that's 1, 2, 3, we see that's the third character there. Okay, so what we're doing is we're passing in what we're looking for, and then we're passing the string that we're looking. That's how car index works. However, we notice that there's actually 4 E's in this sentence. So how would we go about getting the second E? Well, in this case, what we're going to do is we're going to pass the position after that second E, right, which is 3. So we're going to be passing in position 4, and we're going to get that second E. And, of course, my eyes may not be that good, but I'm sitting here looking at it. I want to say it's this one right here. Yeah, that's right, because there's this one and this one. Okay. The sentence is actually very interesting because it has every letter of the English language, but I want to say E appears the most, but maybe not. Maybe O does. I'd have to look at it a long time to figure out which one appears the most. Anyway, so we see it returns, and it returns the 25th character, and that's correct. But what if we want to get the third? Well, again, we'll just apply the same logic. We'll go 1 over, and we see we start at 26 this time because the last one was 25th, and we get that third E, and that is at the 30th, okay? And this is very common in object-oriented programming languages, but that is counting the number of characters in a string. It's a lot easier to do, but we see we can actually do this with T-SQL here, but you can do this with any SQL language. All you're going to do is get the length of the string, and you're going to subtract it to the length of the string, but you're going to replace the character that you're wanting to count with nothing, and so that's going to actually return the number of E's, right? So you could do this with every letter in the English language and figure out which ones appear the most if you wanted to. We also see that we can use car index here to look for words, not letters. And we see when we look at car index of blue, which we know is not in this sentence, we get nothing, right? That's what happens when we try to pass in something that doesn't exist. If we look for the definite article of the, we'll see that there is a the. And notice what it does. It returns where it actually starts. So we see this actually starts first, right? That's correct. So when it passes in that word, it starts at the first place that it appears, and that would actually be in the first one. It's not going to say like 1 through 3. It's not going to say 3. It's going to say that 1. And then we see when we look for the second the, it appears in the 33rd position. So again, every SQL language has derivatives of these or similarities to these, but these are very useful. Now, when it comes to like getting a number of letter or whatnot in a string, and this is my own opinion when it comes to these type of problems, more than likely, if I'm dealing with a specific string and trying to work with a string, I'm going to be using an object-oriented programming language. The reason why they're going to be a lot faster than a set-based language like SQL. Now, it's one thing if I want to apply some type of logic to a set of strings, that might be something where I use SQL, but keep in mind, again, just approaching things from the architecture standpoint, if I know I need to do string manipulation to an entire set of strings, I want to consider storing them appropriately in a way that's going to make them a lot easier to do. So even though we're covering the SQL basics and some functionality, it's good to always have just architecture in the background of our mind, and we want to think about how we can store data to where we can do these type of functionalities with strings much faster than sitting there and just accepting everything and throwing it into a database, and then later on dealing with the complication of, wait a minute, how are you going to write this convoluted SQL over a set of strings where it's going to look uglier and uglier, right? The bread and butter of working with objects is going to be any type of object-oriented programming language. That is not the strength of SQL. You do not want to go row by row and do things. It's just not going to be where it's good. It's good at applying things to sets, right? And so we want to think about how we store our data so that we don't get into these ugly, tricky situations.